Dear students, in this lecture, we will focus on a very important fluid property, that is fluid pressure. Before discussing on fluid pressure, we will see what we mean by fluid statics. Fluid statics, it mainly deals with fluids at rest. So when we talk about fluid pressure, it is a pressure exerted by fluid at rest. Now what is pressure? Consider a surface of area A and a force F acts normal to the surface. So pressure is nothing but the force applied perpendicular to the surface per unit area of the surface. So we can express pressure as force divided by area. Now we will see the unit of pressure. Unit of force is Newton and that of area is meter square. So unit of pressure is Newton per meter square. 1 Newton per meter square is also known as 1 Pascal. 1 bar is 10 raised to 5 pascals. And 1 atmospheric pressure is 101.3 kilonewton per meter square. Now what is atmospheric pressure? It is the pressure exerted by atmosphere around us. And at mean sea level, atmospheric pressure is 101.3 kilopascal. Barometer is the instrument used to measure atmospheric pressure. So here, when the fluid filled within the barometer is mercury, due to the atmospheric pressure, the fluid level within the barometer tube will rise up to a height of 760 millimeter. If you are using water instead of mercury, the rise of fluid will be up to 10.3 meters. So we can say that 1 atmospheric pressure is equivalent to 760 mm of mercury, which is equivalent to 10.3 meters of water. Now we will see different scales of pressure. Pressure can be expressed in two different scales. First one is gauge pressure scale and second one is absolute pressure scale. We will consider two reference lines. Y coordinate represents pressure and the first line represents absolute zero pressure. So along this line the pressure will be 0. You know that at this point the pressure is 0. And the second line represents atmospheric pressure. This vertical ordinate will be atmospheric pressure and its value is 101.3 kilopascal. Now pressure at any point can be measured with respect to absolute zero scale or atmospheric pressure scale. Now let us consider a point A here. Consider a point A. And the pressure at point A can be measured with respect to absolute zero scale and also atmospheric pressure scale. So when we are measuring the pressure with respect to absolute zero scale, it is known as absolute pressure. And when the pressure is measured with respect to atmospheric pressure scale, it is known as gauge pressure. So here, this vertical ordinate from absolute zero scale to point A. So this will be the pressure at point A. This represents absolute pressure at point A. Similarly, the pressure at point A can be measured with respect to the atmospheric pressure scale also. So this ordinate will be known as gauge pressure at point A. So now we can write a relationship between this absolute pressure at point A and gauge pressure at point A. So we can write it as P absolute at point A is equal to the atmospheric pressure plus gauge pressure at point A. That is, absolute pressure is equal to atmospheric pressure plus gauge. Now we have another point B here. So pressure at point B can be expressed with reference to two different scales. So if you are measuring the pressure at point B with respect to absolute pressure scale, this will be the ordinate. So we can represent it as P absolute at point B. Now, if the pressure at point B is expressed from the absolute pressure scale, this ordinate will be known as gauge pressure at point B. Since this point is below the atmospheric pressure line, we can put a negative sign here. So here we can write P absolute at point B is equal to P atmospheric minus P gauge at point B. So here, since point B is below the atmospheric pressure line, we will call it as negative gauge pressure. We will call it as negative gauge pressure or vacuum pressure. We will call it as negative gauge pressure or vacuum pressure, and also we can call it as suction pressure. So we can conclude that absolute pressure is measured with respect to absolute zero scale. Gauge pressure is measured with respect to atmospheric scale, such that pressure at the point is greater than atmospheric pressure. And vacuum pressure is also measured with respect to atmospheric pressure scale, and the pressure at the point is less than atmospheric pressure. When we consider gauge pressure and vacuum pressure, the scale is atmospheric pressure scale, and the atmospheric pressure is considered as 0 in this particular scale. Atmospheric pressure is considered as 0 in this particular scale.